Hello everyone, so today we are going to be solving this question from motion in a straight line. Without wasting any further time, let us get into this video. Okay, so let us read this question first. A woman starts from her home at 9 a.m., walks with a speed of 5 km per hour on a straight road up to her office 2.5 km away, stays at an office up to 5 p.m., and returns home by an auto of a speed 25 km per hour. Choose suitable scales and plot the xt graph of her motion. Okay, what speed she walks with 5 km per hour? Okay, and what distance is the office? 2.5 kilometer away. Okay, and what speed does she come back? 25 km per hour. What time does she start? 9 a.m. She starts to move to the office at 9 a.m. and she leaves office at 5 p.m. Okay, so before solving this question, okay, quickly see this animation so that you will understand. Okay, so it's 9 a.m. So she moves to the office. Okay, then what actually happened? Then she goes. Now, when it's 5 p.m., okay, she comes out, she takes a cab or an auto, okay, then she goes back home. So, if you want, I can show you the animation again. Quickly check the animation. Okay, she starts from her home at 9 a.m. Yes, okay. Now, then she walks a distance how much? 2.5 kilometer. Her office, okay, her office is at a distance of 2.5 kilometers. Her office is at a distance of 2.5 kilometers. Okay, and what speed is she walking with? She is walking with a speed of 5 kilometer per hour. Am I correct? Okay. Okay. So first thing which we have to calculate over here is what time she will reach the office in the morning. So let us set the given data. So office it as is at a distance of 2.5 kilometers. Correct? And what is her speed? Her speed is nothing but 5 kilometer per hour. Okay. Now since there is absolutely no acceleration which is mentioned, you can take acceleration is 0 meter per second square. Okay. So since acceleration is 0, you know that time is nothing but distance traveled upon speed. Okay. So distance is what? 2.5 kilometer. Speed is what? 5 kilometer per hour. So this will give you 0.5 hours, or you can multiply it by 60 and you can get 30 minutes. So which means that she will reach the office. Okay. So when she reaches office at 9:30 a.m. So this is an important point. Okay. 9 a.m. she starts and she reaches office at 9:30. Okay. So remember this. Then what happens? 5 p.m. she what? She comes, she sits in the auto. Then she starts moving. So when does she reach home? When does she reach home? Let us calculate that part now. Okay. So distance will be the same again. So when she is going home, distance will remain the same. Okay. Because she is traveling the same distance. Now, the velocity with which she is going or the auto is going is 25 kilometer per hour. So, what is it again? Time is nothing but distance upon speed or velocity, you can tell over here. So distance is nothing but what? 2.5 by speed or velocity, which is over here with 25. So if you calculate this, you are going to get 0.1 second. Okay, so, which is nothing but 6 what minutes. How? I multiplied this into 60. So how much I got? 6 minutes. So which means that she is going to reach home at 5:06 p.m. Okay. So is this clear? So remember these two things. So this will be helpful for plotting the graph. Okay. So now let us plot the graph. So first important things which we have to know. Okay. Her office what at a distance of what 2.5 kilometers. Okay. Correct? Okay. Yes. And what time did she reach office? Okay. So she started at 9 a.m. and she reached office at 9:30 a.m. Right? Okay. And when did she reach home? She started at 5 p.m. and she reached home at 5:06 p.m. Am I right? Okay. So let us plot the graph. Okay. So what scale I have taken? Scale is important. X axis. Okay. So this is nothing but distance time graph. So in x axis, I have taken time, which is 1 unit or 1 centimeter is equal to how much? 30 minutes. Okay. Here I reckon 9:10. Here there is 9:30. This is 10:30. This is 11:30. Okay. I have not written that over here because it will look clustered. Okay. And what about y-axis? 1 centimeter is equal to what? Same over here. I have taken as point 0.5. Any 0.5 kilometer. Okay. Okay. So let us plot the graph. So what time did she start? She started at 9 a.m. And what was the distance? Well, it was 0. She was at origin. So it will start at over here. Okay. So she started at 9 a.m. This is 9:30. Okay. 10:30. Now she reached office at what time? 9:30. So which is 9:30 and office was at a distance what? 2.5 kilometers. So yani which is this is 2.5. This is 1.5. This is 0.5. 9:30. So 9:30 it is at 2.5 kilometers. Okay. So it was like this. Correct? That's a straight line. Now you can ask why is it a straight line only? Okay. Why can't it be like this? Okay. You can ask that thing. I will give a very simple reason for that. Okay. The simple reason for that is listen over here. You know that distance is equal to speed into time. Now, x is equal to v. Now, this is of the form y is equal to mx. So, which, if you know, is a equation of a straight line. So, that is why here you are getting a straight line. So, I hope this is clear. Okay. Then, from 9:30 okay, onwards till 5 o'clock, she remains in office. So, so this is like this. Okay. So then what actually happened? Okay. This is a straight line. Okay. Now from 5 a.m. She reaches home at 5:06. If this is 5:30, 5:06 is will be somewhere over here, and she reaches like a straight line again. Again, same. Okay, I'll get a straight line. So the graph will be like this and like this. Okay. Here you can see the slope is what high. Correct. Why? Because the velocity with which she was coming back, if you remember, okay, was 25 meter per second, and with which she was going to the office was 5 meter per second. Okay. So that's it for this question. If you have any doubt, let me know in the comments down below. Thank you. Bye bye.